Okay. So good evening to all of you. I hope that everyone of you are doing good. Health wise also, you are also okay. And study wise also. So first of all, how many of you have in the school or how many of you are went to your houses? Give me in the chat box. I just wanted to know that how many of you are at your home right now or how many of you are at your schools? Because I think the vacation is going on in your schools. That's why I'm asking this question. Okay, Bhagat is in the school. Nagashri is also in the school. Priyanka is also in the school. And what about others? JNV North and Middle and Mark. And Christina, Priyadarshini, Suraj, Yamarthi, Shirisha, Piali. Are you in the school or you in your house right now? Okay. So how many of you are able to turn on your camera? I just wanted to see your faces or your classroom, whether you are sitting. Please turn on your camera if possible for everyone. If possible doesn't mean that you cannot open. Okay, you have to open. It's an open up your camera. Bhagat, Nagashri, North and Middle and Mar, Yamarthi, Pyali, S. Rahul, Priyanka. Show me the notebooks where you make the notes of my classes. Are you guys preparing your notes from these classes or not? I'm waiting for your response. Okay. Priyanka is preparing. Is Priyanka the only one? No, no, no. Nagashri has joined the club. Nagashri and Priyanka is the only students that are preparing the notes from Enable Plus classes. Huh? No one else? Okay. Their destiny, their ways, what we can do right now. Okay. So first of all, we have started with the magnetic part of our physics. It try to attract you and you have to be attracted towards it because it's magnetism. Okay. So magnetism we have started a very important unit by the point of view of both examination, whether you talk about NEET or you talk about JEE means, the point of view of both the examination, this unit is very important. So in the previous classes I have a brief you about Lorentz force, not Lorentz Visnoy. It's the Lorentz force that I'm talking about. So Lorentz force ke bare mein we have talked in the previous session. We have seen that how magnetic field affect a charged particle when it's moved with certain speed, and what is the direction, possible direction of the motion, possible direction of the force. All we have talked in the previous session. Now we are going to revise that one also. After that, I have also talked about the Orested experiment in the previous session. That when Orested has a demonstration, giving the demonstration in front of other scientists or physicists, he had observed that the current carrying wire also deflecting a magnetic needle. So there is a possibility that current will also, the moving charges will also generate the magnetic field. And due to that reason, we will study the Biot-Savart law. Okay. After that, we apply the Biot-Savart law, the various application we are going to see. in terms of magnetic field due to various conductors and rest on. Okay, we will see some numericals also, mostly previous years or conceptual questions. So this lecture is going to be very interesting if you just focus enough and very learnable. Okay, चलिए तो फिर स्टार्ट करते हैं. सबसे पहले रिवीजन में we have talked about the Lorentz force. The Lorentz force is equals to F vector total force. अगर कोई charge particle moving in a electric field and magnetic field is also present. यहाँ पे charge particle is not generating the magnetic field. Charge particle is entered in a field where both fields are present, electric field and magnetic. Okay. So this particular B here is not the field that is generated by the charge. ठीक है. So this B here, just a sec. Give me a sec. हाँ. So यहाँ पे ये जो B vector है ना, this B vector is the external magnetic field. Always remember, external magnetic field. Okay, clear? So this complete expression is for total force when the charge is present in electric field and magnetic field. Electric field का force is q e vector and magnetic field का force is q v vector cross b vector. Now, work done by the magnetic Lorentz force. Magnetic Lorentz force is only Fm, or magnetic force you can also say it. You can also say it magnetic force Q. So I have told you that this magnetic force can be zero if V is zero, B is zero, and theta is zero. Since we know that the work done by the magnetic force is zero, why? Why the magnetic force work done is zero? Because you know when the particle move with certain velocity, then it will cover some displacement. Suppose this is the direction of velocity, but the force vector is always perpendicular to the velocity. Always perpendicular to the velocity. So this force vector is always perpendicular to velocity. So that is why whatever the displacement the body or the particle will have, having with a 90-degree angle with force. And what is work done basically? Work done is force dot displacement. Force dot displacement will become what? Zero, because it will become ft cos of theta. Theta is 90 degree. Cos 90 is zero. So work done by the magnetic force is always zero. Similarly, the power generated, if there is no work done, there is no power. Okay. So also we can use the same analogy that F is perpendicular to velocity. So F dot V, which is nothing but power, is equals to zero. So power delivered by the magnetic force is also zero, since the work done by the magnetic force is zero. Okay. Clear? Now, try to solve this question and let me know the answer very soon. Okay, rapidly answer this question. Question is from JEE Main 2024. Recent, very recent question. Okay, look how simple the question is in JEE Main. The electrostatic force F1 and magnetic force F2 acting on a charge Q is moving with velocity V can be written as. बताओ. It's a very easy one. Giving you 30 seconds to solve this question. And there is nothing like solving in this question. Simple statement based question. Formula based. You know the formula, you know the answer. Let's say who is going to crack JEE. Priyanka Nagashri has made that point. Very good, guys. Okay. So, if you talk about very good Yamarthi, गणेश, वेरी गुड। देखो, वी हैव टॉक्ड अबाउट द इलेक्ट्रिक फील्ड इज क्यू ई वेक्टर एंड मैग्नेटिक फील्ड इज क्यू वी वेक्टर क्रॉस बी वेक्टर. So option C is the correct one. There is no discussion. There is no point of discussion in this question. Okay. Very good to all of you. Those have answered C. Now try to solve this question. This question is also for you. A charged particle have charge 2 coulomb is thrown with velocity 2 I cap plus 3 j cap inside a region having electric field 2 j cap and magnetic field 5 k cap. Find the initial Lorentz force on the particle. सबसे पहले what we will do, देखो, सारे क्वेश्चन सोल्व करना सिखा दूंगा. जस्ट यू हैव टू पे द अटेंशन. First of all, what is given in the question, you have to write that. So here given data is what? Let me change the color. Na? Both will be the same color then. This given data के बारे में बात. The given data is that velocity vector is given to you 2 I cap plus 3 j. Electric field vector is 2 j cap, and we can also write the unit here. And what will be the unit? Coulomb per meter. सही है यूनिट. चलो यूनिट बताओ इलेक्ट्रिक फील्ड की. इट विल बी न्यूटन पर कूलम. ठीक है. इलेक्ट्रिक फील्ड इज नथिंग बट फोर्स पर यूनिट चार्ज. सो दैट इज दिस. एंड मैग्नेटिक फील्ड इज बी वेक्टर इज 5 k कैप टेस्ला. देखो, टेस्ला इज द यूनिट इन एसआई सिस्टम. यहाँ पे सब कुछ मीटर सेकेंड में गिवन है, कूलम में गिवन है. सो दिस यूनिट वी आर गोइंग टू यूज फॉर सीजीएस यूनिट. सीजीएस यूनिट क्या है? इज गॉस. ठीक है, गॉस. क्लियर है. नाउ अप्लाई द formula. We know that what is been asked, Lorentz force. So F is equals to Q E vector plus Q V vector cross B vector. How to solve a cross product? Make a matrix. First row is I cap, J cap, K cap. Second row is the component of first vector, which is velocity vector, 2 I cap plus 3 0 K cap. And component of third B vector is 5 K cap. And although you can see here, this vector, velocity vector, is in ij, xy plane. This is y, this is x. So this is the velocity vector. The magnetic field is present in z cap, z direction. K cap is the unit vector of z direction. So magnetic field is this, which means both are perpendicular to each other. We can say that xy plane is perpendicular to z axis. So by this analogy we can do also. ठीक है. इस तरीके से भी क्वेश्चन को सोल्व कर सकते हैं, सिंपल रीजनिंग लगा कर. ठीक है. अदरवाइज ये ऑप्शन तो है ही है. तो ये दोनों जीरो हैं. इस रो के अबाउट एक्सपेंड कर देंगे. 3 आई कैप 2 जे कैप और 5 से मल्टीप्लाई कर देंगे. क्लियर. नाउ सिंस वी नो दैट द एंगल बिटवीन मैग्नेटिक फील्ड and the velocity vector is 90 degree. So we can directly open it. QE vector plus QVB. Sin 90 will become 1. Velocity is 2 I cap plus 3 j cap. Cross product with 5 k cap. ठीक है. अभी मैग्नीट्यूड निकालना है तो दोनों का मैग्नीट्यूड ले लेंगे, क्योंकि दोनों वेक्टर 90 डिग्री पर है, एक दूसरे से परपेंडिकुलर है. So we can say that Q is nothing but 2 coulomb, 2 into 2 j cap, ठीक है, प्लस मैग्नीट्यूड के लिए तो मैट्रिक्स पे जाना ही पड़ेगा, आई जे के 2 3 0, और ये हो जाएगा 0 0 5, ठीक है। अब देखो, इस रो के अबाउट 0 0 वाली रो के अबाउट एक्सपेंड करेंगे, फर्स्ट जीरो से एक्सपेंड करेंगे तो सब जीरो हो जाएगा, सेकंड जीरो विल मेक एवरीथिंग जीरो। नाउ द 5 इज ओनली रिमेनिंग थिंग, सो इट विल बी 5 इंटू 3 i cap minus 2 j cap, ओके। एंड q की वैल्यू इज ऑल्सो, तो 2 5 जा 10, 10 3 जा 30, 30 i cap minus 2 5 जा 10, 10 2 जा 20, minus 20 j cap, and minus 20 plus 4 will become 16 j cap. So this is the initial force vector, ठीक है, clear है? Any kind of doubt, guys? If anyone has any kind of doubt, you can ask right now. Now we will be discussing today's topic, that is Biot-Savart law. Okay. In the topic PPT, in the topic slide, the Savart spelling is incorrect, so please correct here. SAVART. Okay. In this question, anyone has any kind of doubt? Yes and no? Yes and no तो एकदम से बता दिया करो, ठीक है, so that why मैं आगे बढ़ सकूं, I move forward with your responses. Okay. Now, Biot-Savart law. What is Biot-Savart law and why do we need it? ठीक है, first of all, Oersted make Biot-Savart interested in this phenomena, ठीक है, because Oersted has demonstrated that a current carrying wire can also develop a magnetic field around, near and around it, right? So near around it, how we determine that, what is the magnitude of that field, ठीक है, how this magnetic field behave, ठीक है, what is the direction of that magnetic field, will be a variable magnetic field or a constant one? So lot of questions arises the mind, ठीक है, in the curious mind. So Biot-Savart was the one who has answered this and demonstrated it in front of us, ठीक है, and open up the new possibilities in physics. So first of all, what is the statement of Biot-Savart law? It's very clear. According to Biot-Savart law, the magnetic field, which is dB. Why dB? Because we are considering a very small length. Okay, dl is a very small length. So dB vector is proportional to current. dB is directly proportional to current and the elemental length dl, and inversely proportional to the square of the distances r. Okay. So dB vector is directly proportional to I into dl vector cross r vector divided by r cube. Okay. Now you will question कि in the statement dB is only proportional to I and dl. So this dl vector cross r vector is just to show the direction, because dB is a vector field. So that is why we need to determine what is the direction of that field. So that is why we have taken dl cross r vector here. Okay. When you want to know what is the magnitude of this dB, so it will be dB vector. Open up this expression, it will become mu I dl r sin theta n cap mu naught upon 4 pi I dl r of sin theta n cap. R and r will cancel out, so it will become mu naught I dl upon r square sin theta n cap, where n cap is the unit vector in the direction of dB. ठीक है, so this is the dl. What the dl is called? Elemental length, or dl is also termed as current element. क्या बोलते हैं हम इसे? Current element. Current element is what? dl. Why current element? Because we consider the flow of current through this elemental length, so that is why it is termed as current element also. ठीक है, current element की direction क्या होगी? So whatever is the direction of current, Since in this question current is moving up, so direction of dl vector is also up. Okay, here to here, low to high. This r vector is the position vector of that point where we want to calculate the magnetic field. Okay, since this dl is very small, so the field developed here will be very small. Clear है? Theta is the angle between dl vector and r vector. Clear? Theta is the angle between dl vector, current element, and the angle between the position of that particular point. ठीक है? Now, okay, angle हो गया, dl हो गया. Now, how to determine the direction of this? Okay. इस क्वेश्चन पे आएंगे, फिर पहले डायरेक्शन के बारे में बात कर लेते हैं. देखो, dl और r, dl is the current element which is selected on the wire or the current carrying element. ठीक है, उसमें ही dl को सिलेक्ट करना. एंड r वेक्टर इज द पोजीशन वेक्टर फ्रॉम दैट elemental length to that point where we want to calculate the magnetic. So दोनों के दोनों क्या हुए, सेम प्लेन में. dl भी इधर ही है, r वेक्टर भी इधर ही, दोनों के दोनों सेम प्लेन में. बट जो मैग्नेटिक फील्ड डेवलप हो रही है दैट विल बी परपेंडिकुलर टू बोथ ऑफ देम, dl वेक्टर के भी और r वेक्टर. So always remember this magnetic field that is being developed is perpendicular to dl vector and r both. Now इस क्वेश्चन को करेंगे when we talked about the direction first. So direction के बारे में as we have already have an introduction about Lorentz force का direction in the previous session. So I'm not going to elaborate much on that. This is a cross product. So cross product की direction आप simple निकाल सकते हैं. dl cross r. Put your palm, ठीक है, in such a way that it will facing the another vector. One vector is dl. So place your palm, right hand palm, in the direction of dl, and it is facing the another vector, and then curl your finger, you will get the direction of another vector. ठीक है, the resultant vector of cross product. So here also you can see that the direction of db is in the direction of cross product of dl and r vector. राइट हैंड थंब रूल से भी हम डायरेक्शन को पता कर सकते हैं. कैसे करेंगे, देखो, ये आपका जो थंब है, प्लेस योर थंब इन द डायरेक्शन ऑफ करंट और इन द डायरेक्शन ऑफ करंट एलिमेंट. करंट एलिमेंट की डायरेक्शन में फिंगर पुट करो एंड देन कर्ल योर फिंगर. whether your finger is going, where your finger is going, into the plane. So the field developed at that point is the into the plane. But look at this, when you calculate the current magnetic field on another side, okay, then the finger is coming outward, out of the plane, which means at that point the magnetic field will be out of the plane. So by this analogy we can see that at one point the magnetic field is inside, at the another point the magnetic field is outside, which means that a magnetic field is a circular loop. Okay, like this. So magnetic field making a closed loop in that field. Okay, क्लियर है सभी को? एनी काइंड ऑफ डाउट? अब देखो, इस सिचुएशन में देखो, dl is moving up in the direction of current. dl is not moving, the direction of dl is upward, like this. Place your finger in the direction of dl and curl your finger. The db is going into the plane, which means that is a cross. Why the cross? Just give me a second, guys. Huh? So sorry, guys, for the interruption. So what we are talking about the cross. Cross means into the plane, and dot means at this point. If you calculate the field at this point, the field is coming outward, so we will be denoting it by a point. Why it is so? देखो वेक्टर को भी डिनोट विद एन एरो, और एरो कैसे होता है, ऐसे होता है ना। एरो का बैक साइड अगर आप देखोगे तो क्रॉस ही तो होता है, और फ्रंट साइड आप देखोगे तो एक डॉट होता है। यू लुक एट द एरो, in the front side it will look like a dot, in the back side it will look like a cross. So cross means the arrow is going inward, which means vector is inside, and dot means vector is outside, coming outward. Okay, that is the simple trick. Now try this question and try to solve by your own. Okay, I'm giving you 1 minute to solve this question. Try to solve this question by your own. देखो जेई मेन से क्वेश्चन है, प्रीवियस ईयर क्वेश्चन है, recent क्वेश्चन है। An element of delta L length, which is delta xi, which means what is delta L is what, current element। देखो यहाँ पे भी एलिमेंट ही डिनोट किया है, बट इन योर माइंड इट शुड बी क्लिक्ड एज अ करंट एलिमेंट। ठीक है, सो डेल्टा एल इज इक्वल टू डेल्टा एक्स आई कैप is placed at the origin and current carries a large current I is equal to 10 ampere. The magnetic field on the y-axis at a distance of 0.5 meter from the element delta x of 1 centimeter length। ये जो लेंथ है 1 सेंटीमीटर है, एंड 0.5। अब देखो ओनली लेंथ इज मेंशन, विड्थ इज नॉट मेंशन। ठीक है, बाय गिविंग द फिगर ना इट विल ट्राई टू कंफ्यूज यू। ठीक है, देन यू विल आस्क कि ये वाली डिस्टेंस क्या है, डिस्टेंस तो पॉइंट की यहां से है। नो नो नो, डोंट गो इन दैट पिट होल। ठीक है, बिकॉज हियर ओनली वन लेंथ, लेंथ ऑफ द डेल्टा एक्स इज मेंशन, व्हिच मींस देयर इज नो विड्थ। ठीक है, सो 0.5 इज द कंप्लीट डिस्टेंस एट दिस पॉइंट। ठीक है, सो व्हाट वी विल डू, देखो वी नो दैट b is equals to what, mu node upon 4 pi I dl साइन थीटा अपॉन आर स्क्वायर। देखो सब कुछ तो गिवन है। म्यू नॉट अपॉन 4 पाई की वैल्यू होती है 10 रेज टू द पावर -7, वेयर म्यू नॉट इज द परमिएबिलिटी ऑफ फ्री स्पेस। ठीक है, आई इज आल्सो गिवन टू यू एज 10, dl is given to you as what, dl is 1 centimeter, the length of the current element is 1 centimeter, which is 1 into 10 raised to the power -2। Sin theta is what, देखो this is the r vector। r vector किसका, पोजीशन, where we want to calculate the field at this point p। और ये हमारा एलिमेंट हो गया, एलिमेंट इज इन x डायरेक्शन, पोजीशन इज इन y डायरेक्शन, so angle between them is 90 degree। sin 90 is 1 divided by what is r, r is 0.5 meter, 0.5 into 0.5। ठीक है, देखो पॉइंट हटाने के लिए 10 से मल्टीप्लाई डिवाइड करेंगे, सीधा ही हटा देंगे, सीधा 100 से मल्टीप्लाई कर देंगे ऊपर, ये कैंसिल हो गया। अब ये क्या बना, 25, 10 अपॉन 25, 10 रेज टू द पावर -7, अगेन 5 टू जा 10, 5 5 जा 15, it will be 0.4 into 10 raised to the power -7, or you can simply say 4 into 10 raised to the power -8। What is the unit? Unit is Tesla, because we have converted all the unit in SI system. So magnetic field is 4 into 10 raised to the power -8 Tesla। When we will studying the magnetic flux na, at that time you will get to know one another unit, which is Weber per meter square। ठीक है, this is also the unit of magnetic। Clear है everyone? Any kind of doubt in this? Okay. Let's move to the similarities and differences between Biot and Savart law. Biot-Savart law and Coulomb's law. Because why the similarities, why the differences? Because देखो, Coulomb's law is also inverse square law। Coulomb's law is what? F is equals to K Q1 Q2 upon R square। This force is also in electric field। This is force is also applied in a field. This Biot-Savart law is also creating a demonstrating a magnetic field. A kind of field is there. So that is why we are discussing the similarities and differences. यहाँ से एक assertion region type of question बन सकता है और true false question भी बन सकते हैं. ठीक है. So please pay attention to this topic. So both are long range because both depends on the inverse square. Whatever the law following inverse square, it will be valid for smaller smaller distances and very large distances also. Same as the gravitational. Gravitational force is also valid for proton or neutron. ठीक है. Very small particles, very close to each other. At that point also the gravitational force is valid, and it is valid for interstellar spaces. ठीक है. When we talk about light years, the separation is in light years. ठीक है. Second thing is the principle of superposition applied to both. ठीक है. Principle of superposition is what? If there are certain charges given in the system, so the magnetic field of generated the electric field generated by one charge particle is not disturbed by the another. In similarly, when multiples of current carrying conductor is present, so the magnetic field developed by one wire is not disturbed by the another one. Or we can say that the net magnetic field at that situation will be the vector sum of all that. Okay, clear? Magnetic field is linear inside the source because why the linear? Because magnetic field is directly proportional to IDL vector. DL is a linear vector. Okay, so that is why magnetic field is linear inside the source, just as the electrostatic field linear inside the source. ठीक है. इलेक्ट्रोस्टैटिक फील्ड भी क्या होती है किसी चार्ज के अंदर? लीनियर होती है. इन सिमिलर वे मैग्नेटिक फील्ड भी क्या होती है किसी सोर्स के अंदर जहां से मैग्नेटिक फील्ड आ रही है? लीनियर. ठीक है. इलेक्ट्रोस्टैटिक फील्ड इज प्रोड्यूस्ड बाय स्केलर सोर्स. कौन सा स्केलर सोर्स? चार्ज. इलेक्ट्रिक फील्ड कहां से डेवलप होती है? चार्ज से पैदा होती है. ठीक है. वाइल मैग्नेटिक फील्ड इज डेवलप्ड बाय विच? अ वेक्टर एलिमेंट, क्योंकि डीएल क्रॉस आर से पैदा हो रही है ये डीएल वेक्टर क्रॉस आर से. ठीक है. सो दिस इज द ओनली डिफरेंस कि इलेक्ट्रिक फील्ड इज प्रोड्यूस्ड बाय ए स्केलर सोर्स while magnetic field is developed or produced by a vector. ये बहुत इंपॉर्टेंट पॉइंट हो सकता है. Now there is angle dependency in Biot-Savart law. Similar, we can say that because that magnetic field is depends on ideal sine theta by r square. So depending on sine theta, and theta is the angle between current element and the position vector. But have you seen any angle in electrostatic field? No. It's simply kq by r square. Okay. So the angle dependency is absent in electrostatic field while it is present in magnetic. Remember these points. Now move on to the next topic. Magnetic field due to various current carrying conductor. Okay. देखो, this is the application of Biot-Savart. Here in this situation we have considered a magnetic field due to a thin straight current carrying conductor. Thin straight current carrying conductor. Okay. So you can see simply this is the current carrying element or the conductor in which I current is flow from here to here. Let's say from point A to point B, the current I is flow, and we are interested to find out the field at this point P, which is perpendicularly a distance away from the current carrying conductor. So the final expression that we got now, its magnetic field at point P due to current carrying wire is B vector is equals to mu naught upon 4 pi a, the perpendicular distance between them, into sine phi 1 plus sine phi 2. Now what is this phi 1? What is this phi 2? I have just given you idea that this is the expression that we want to reduce here. Okay. Now here we will talk about this, the derivation part. देखो, this is the point P where we want to calculate the magnetic. This is the current carrying wire. in which I current is flow, we have considered a current element here in the direction of magnetic field, which is dl vector. Okay, dl vector. Now, in Biot-Savart law, what is that? db vector is given by mu naught upon 4 pi I dl vector cross r vector divided by r, or simply mu naught upon 4 pi I dl sin theta upon r square, which means sin theta is important. So if you just locate this point from dl, that will be the vector line. This this one will be the vector line. So this is the position vector r vector. और r vector से which angle is that? Pi minus alpha. ठीक है, क्लियर है? देखो वन बाय वन मूव करेंगे. So first of all we know that db vector is nothing but mu naught upon 4 pi I dl sin theta, not this theta, another theta. Okay, upon r square. This is equation number 1. Now put the values. We know that. तो सबसे पहले dl वेक्टर और r वेक्टर के बीच का एंगल भी नो, इट इज पाई माइनस अल्फा. So we putting this value here. db vector is equals to mu naught upon 4 pi I dl sin theta will become sin. अब देखो एंगल इज पाई माइनस अल्फा, पाई माइनस अल्फा. But what is sin pi minus alpha? It's in the second quadrant, and in second quadrant sin will be positive, so it will be same as sin alpha. So can I write sin pi minus alpha as sin alpha? Yes, we can write. So it will become sin alpha divided by r square. This is the r. Okay, and let's say this distance, this particular length is from O to dl is L, small l, and this particular length from this point O to this point P is, let's say, A. Okay. Now, can I replace this dl in terms of fixed quantities? Fixed quantity क्या है? A है. This distance will never going to change. अगर मैं ये पॉइंट यहाँ पे कंसिडर कर लेता हूँ A डिस्टेंस, डिस्टेंस तो सेम ही रहेगी ना. सो आई वॉन्ट दिस dl इन टर्म्स ऑफ A. ठीक है, क्लियर है? चलो देखो, फाई वन क्या है यहाँ पे? फाई वन इज द extreme angle of one of the end of the current carrying wire from the midpoint. This O is the midpoint of the wire, and not the midpoint, any general point. So at any general point, phi 1 is the extreme angle of one end, phi 2 is the extreme angle of another end. Okay. Now, and theta is the angle of current element with this origin. Okay. With this point P say current element at which angle is present, this is given by angle theta. चलो सारी बातें हो गई हैं. अब देखो डीएल के बारे में बात करते हैं. सबसे पहले एल को रिलेट करेंगे इन टर्म्स ऑफ. देखो we can write L is nothing but in this small triangle, if you will see in this small triangle of theta, this is L, this is R, and this is A. ठीक है. So we can say that L is nothing but the perpendicular component of R. ठीक है. So we can say that L cos theta is equals to R. ठीक है, क्लियर है? सॉरी, L sin theta. L sin theta is small r. ठीक है, और ये क्या है? A cos theta is what? L sin theta is the perpendicular component of R. R perpendicular and R parallel is A cos theta. ठीक है. Now, चलो forget about this. Use the different analogy. ये थोड़ा tough हो जाएगा. देखो, if I apply the tan theta here in this triangle, so what it will become? L by A बन जाएगा. तो यहाँ से मेरे पास सिंपल एक रिलेशन आ रहा है that A is equals to L upon L is equals to A tan theta. ठीक है. अब देखो मेरे पास रिलेशन आया है L is equals to A tan theta. If I differentiate this, it will become DL into A. A is a constant distance, so it will never going to differentiate. Tan theta का differentiation will be sec square theta into d theta. Now put this in one, not one. This put it in one. So dB vector will become mu naught upon 4 pi I. dl के प्लेस पे क्या लिखना है? A sec square theta d theta into sin alpha. What if I just convert this alpha into theta, because the integrand is present in terms of d theta, so I have to replace this alpha also and this r also. ठीक है. तो r तो we have already calculated. R is nothing but r का cos component, पैरेलल component क्या है? A cos theta. ठीक है. which means r cos theta is equals to what? A. तो यहां से मैं r को in terms of A लिख सकता हूं. R is nothing but A sec theta. ठीक है. तो यहाँ पे A की वैल्यू रख देंगे, R की वैल्यू रखेंगे. Let me change the color. So dB will become mu naught upon 4 pi I A sin अल्फा. देखो अल्फा को भी रिप्लेस कर लेते हैं साथ ही साथ. अल्फा इज नथिंग बट व्हाट? देखो, अल्फा इज दिस एंगल एंड दिस इज थीटा. सो कैन वी से दैट 90 माइनस अल्फा और 90 माइनस थीटा is equals to alpha. So we can replace alpha by 90 minus theta. It will become 90 minus theta sec square theta d theta. ठीक है. डिवाइडेड बाय आर स्क्वायर की वैल्यू क्या है? ए स्क्वायर सेक स्क्वायर थीटा. ए स्क्वायर सेक स्क्वायर थीटा इज द वैल्यू ऑफ आर. ठीक है. सो यहां से sec square theta will be cancelled out. One of the a will cancel out. Now what will be remaining? Let me write in the next stage. So dB vector here is what? Mu naught upon 4 pi into I sin theta d theta. Or sin theta is or what? Sin 90 minus theta is what? Tell me in the comment box. What is the value of sin 90 minus theta? Now to calculate the net field, everyone, no one is responding. Why is so? B net is given by the integration of B vector. Okay. Integration of B vector mu naught upon 4 pi is the constant. So we will take it out as a integration. Now I is also constant. So I will be also coming out of the integration. Here we have only cos theta into theta. Okay. What will be the limit? देखो, limit will be, we have to put in terms of theta. What is the variation of theta? That we have to determine. Theta can vary from phi 2 to phi 1, but can theta vary in the similar sense? Like the sense when you cover the phi 1 is anti-clockwise, sorry, clockwise. But when you move to the phi 2, it will be anti-clockwise. Okay? So you have to put phi 2 as minus phi and then phi. Okay? Clear? Now, B net is equals to mu naught I upon 4 pi e into integration of cos theta is nothing but sin theta plus sin theta. Always remember. Okay? In limit from phi to minus phi 2 to phi. Why this is minus phi 2? Because the sense is opposite. When you putting the value of theta, sense is opposite. Now, B net is equals to mu naught I upon 4 pi a sin phi 1 plus sin phi. Why plus? Because it is coming as minus. Minus sin minus phi 2. Sin has a property that sin minus theta will be minus sin theta. ठीक है, तो ये माइनस क्या आ जाएगा, बाहर आ जाएगा, it will be vomit out. So that is why I'm writing it as phi 2 and this will be plus. So this is the final expression of a current carrying, thin current carrying straight conductor, the magnetic field at that point. Okay. Few points that you need to remember. Suppose we have calculated by assuming that this point is in the range of the current carrying conductor. The P is in the range of current carrying conductor. But what if this point is out of the range of current carrying conductor? Let's say here is the point. So what will you do? Just connect it like this and extend the wire. Assumely, only assume that you are extending the wire. Now calculate this angle as phi 2 and put it as minus phi 2. Suppose this angle is coming out as 30. Okay. So you have to put phi 2 is equals to minus 30. Clear? And this angle, not this particular angle. This particular angle have to put as 5. Okay, suppose this is coming out as 60. So put 5 and as 60. Okay, that is how you are going to solve the questions. Now, discuss the various cases in this case. Let me do it very quickly so that we can cover it by today itself. देखो, case 1 क्या है? When phi 1 is phi 2. Phi 1 is phi 2 का मतलब क्या हुआ? The point is present at the perpendicular angle bisector. ठीक है? At the midway of the conducting wire. Phi 1 is equals to phi 2 का क्या मतलब हुआ? The point is present at the mid. Clear? So at that point is, this is also termed as perpendicular bisector. Okay. When the point is present at the perpendicular bisector. So in this case, you will do phi 1 is equals to phi 2. So magnetic field vector will be mu naught upon 4 pi. The magnitude mu naught upon 4 pi a sin phi 1 into sin phi 2. So it will become 2 sin phi. 2 and 4 will cancel out. So mu naught I upon 2 pi a into sin phi. This. When the wire is semi-infinite wire means one end is at the finite location. Suppose this is the wire. One end is at infinity, another end is at a particular position, let's say O. And here the point P, where we want to calculate the magnetic. So this is the arrangement of semi-infinite wire. It can be like this. Point is present here. Okay. So in this case, one of the angle is 0 because point is present at this point. Okay, when you connect this, one of the angle, let's say phi 2 will become 0. Phi 2 is 0 in this case. This is the situation, na? This is wire, this is point P. We have extended this point here. So this angle will also becoming 0. So phi 2 will become 0. And phi 1, the angle that you need to connect this point to the infinity. So this phi 1 will become 90 degree. Okay? Because at infinity, both the lines, the line of the wire and the line of the point will become parallel. So phi 1 is 90 degree. Okay? Clear? Phi 1 is this angle. This angle will become 90 when these wire will become perpendicular. So in that case, what will be the magnetic field? Mu naught upon 4 pi into sin phi 1 plus sin phi 2. Sin phi 1 is 90, sin 90 is 1, and sin phi 2 is 0, sin 0 is 0. So it will be mu naught upon 4 pi, mu naught I upon 4 pi for semi-infinite. What is for case third? For infinite wire. Infinite wire के लिए phi 1 is equals to phi 2 is equals to 90 degree. This is the condition. So here the magnetic field is come out as mu naught I upon 2 pi A. It is half of the semi-infinite, twice of the semi-infinite. ठीक है ना? Semi-infinite में क्या था? Mu naught upon 4 pi A. Just double it, so you will have the 4 infinite wire. Clear? What if the point is present in the line? If point is present on the wire, वायर पे ही अगर पॉइंट आ गया देन मैग्नेटिक फील्ड इज 0. एंगल विल बिकम देन, ठीक है. So here magnetic field due to current carrying loop we have to discuss. ठीक है. We have 5 minutes, so we can discuss it. Look, whenever we talk about a current carrying loop, it's a conducting loop we are talking about. So firstly, you need to very clear about the direction of the magnetic field. ठीक है. Direction is given by what? देखो, this is the current carrying loop. मैंने क्या बताया था? जस्ट कर्ल योर फिंगर इन द डायरेक्शन ऑफ द करंट फ्लो. ठीक है. करंट ऐसे फ्लो हो रहा है, करंट ऐसे फ्लो हो रहा है, तो थंब इज द डायरेक्शन ऑफ मैग्नेटिक. ठीक है. सो इन दिस लूप इफ यू विल सी, लेट्स से दिस इज द लूप, दिस इज द करंट कैरिंग लूप. ठीक है. इसमें करंट इस तरह से फ्लो हो रहा है. कौन सी सेंस है? एंटी क्लॉकवाइज सेंस में फ्लो हो रहा है. व्हाट इज द मैग्नेटिक फील्ड एट दिस पॉइंट? सो व्हाट यू विल डू, just curl your finger in the direction of current flow, and the thumb represents the flow of the magnetic field. So this will be the magnetic field here. ठीक है. You can also solve it by the previous method. उसमें क्या था? आपको करंट एलिमेंट कंसिडर करना. कंसिडर अ करंट एलिमेंट आपने कंसिडर कर लिया. यहाँ पे वो पॉइंट पी है वेयर यू वांट टू कैलकुलेट द फील्ड. सो जॉइन इट. ठीक है. वी हैव जॉइंड इट. नाउ डीएल is in this direction and R is in this direction. So curl your finger from DL to R. The thumb is coming up. That's why you can say that. What if the field is outside here at this point? The current is moving in this direction. Put the finger, put your thumb in the direction of current and curl your finger. So देखो, same way में, the same way which is shown in this figure. If you will see, let me change the current here. देखो, here we have considered a very small current element. ठीक है. इस करंट एलिमेंट से यहाँ पे फील्ड कैसे कैलकुलेट करेंगे? आउटसाइड. इस पॉइंट पे। सो करंट, जो थोड़ा सा इमेजिनेशन आपको करना पड़ेगा, द डीएल एलिमेंट इज इनसाइड, आर इज इन दिस डायरेक्शन, सो डीएल क्रॉस आर इज, लेट्स से dl cross r is will become this. So it will be coming out as a circular loop of magnetic field. और इसका सबसे इजी मेथड क्या है, करंट की डायरेक्शन में अपने थंब को प्लेस कर लो एंड देन कर्ल योर फिंगर, ठीक है। सो कैलकुलेट एट दिस पॉइंट, देखो करंट इज मूविंग लाइक दिस, ऐसे मूव कर रहे हैं। यहाँ जब ऊपर वाले पॉइंट पर है तो करंट इज गोइंग लाइक दिस, पुट योर थंब इन दिस डायरेक्शन एंड कर्ल योर फिंगर, व्हाट इज द डायरेक्शन इज कमिंग आउट, द डायरेक्शन इज clockwise. Look at the loop. Loop is also clockwise. Okay. So magnetic field due to a current carrying loop, if you want to calculate, this is the loop. We want to calculate the magnetic field at the axis of the loop. In the same way we have did with the electric field when we have calculated the electric field due to a ring. Okay. This is the same case. So here at the point where we want to calculate the magnetic field, this is point is P, let's say. So we have considered a current element here of dl length. We connect it to this point P. So this will become what? R vector. ठीक है, dl cross r से what is the direction of db? db is coming out, dl, this is dl coming towards me, the dl is there and this is r, so dl cross r is perpendicular to this point, ठीक है, क्लियर। सो ये जो टोटल एंगल होगा ये 90 डिग्री होगा, जो आर वेक्टर से ये बना रहा होगा मैग्नेटिक। सिमिलरली इफ यू कंसिडर करंट एलिमेंट हियर, so both the thing will remain same, but the direction of the magnetic field will be disturbed. Exactly mirror image, because this is the symmetric object that you have chosen. So whatever the magnetic field or electric field is conceived by the upper part, similar way may the same field will be conceived by the lower part, but in the opposite, exactly mirror opposite. So you can see these two things. When you calculate the component of that, this will be the db cos theta, db cos theta, and this component will become db sin theta, ठीक है, क्लियर। अब देखो db cos theta इसी का भी एक आएगा, db cos theta डाउनवर्ड and db cos theta in the same direction. So same direction wale we can add up and the opposite direction we can cancel it out. So by doing that, we get to know that the resultant field at this point will become mu naught upon 4 pi I into 2 pi capital R square divided by R square plus X square raised to the power 3 by 2. You have to remember this formula. Okay. So how to utilize this formula in JEE means or the numericals, I will show you in the next class. Next class may we will be doing some problem solving, and so I have launched a poll. First of all, answer in that poll and then mark your attendance in the chat box. Okay. Please do mark your attendance after responding in the poll. If you do not respond in the poll, then we will not mark your attendance. So it's very mandatory to mark your attendance and to mark in the poll. Okay, everyone. In the next class, we will be discussing some questions on the magnetic field due to current loop, and the next topic, which is Ampere circuital law, we will be discussing in the next class. Okay. If in this class, if you have any doubt, you can ask. Otherwise, the lecture is being over. Thank you so much for being attentive and being responsive in the class. Bye bye. Take care.